Okay, the apparatus in the diagram, this is question number 2, is used to collect oxygen produced by the decomposition of hydrogen peroxide. So to collect oxygen produced, so that means oxygen is going to be a product. And the decomposition of hydrogen peroxide, so that means hydrogen peroxide is going to be a reactant. Decomposition means the breaking down, so there is only one reactant. That's a H2O2. To produce oxygen O2, and the other product is water, H2O. Okay, so the next step then would be to balance the equation. So in a mark scheme, usually you get 1 mark for having the correct formula of both reactants and products. So you'd already be on 1 mark by now. But the next step is to balance the equation. So we've got 2 oxygens on this side, 2 on this side, but 1 more here, 3. So we're going to have to make sure our oxygens come in an even number, because they're in an even number here in the reactant side. So the first step is to put a 2 here. So we now have 2 times 2 is 4 hydrogen. So we also need a 2 here. 2 times 2 is 4 hydrogen on this side. And then our oxygen, we have 2 on this side and 2 more. 2 times 2 is 4, so we're now balanced. Okay. So the next thing, oh, by the way, you just had to remember that the hydrogen peroxide breaks down to give you oxygen and water. A hint is as well is that you've got like a solution here, and the only thing that's being collected is oxygen. So it couldn't be the other gas, it couldn't be hydrogen gas. But again, you just have to learn off that it's oxygen produced. They told you it was oxygen, and you could figure out then that water was the other one. Or even better, you learnt it and you remembered it from doing it in lessons. So the next question is to describe a test that shows that gas collected in a syringe is oxygen. So it's asking you what the chemical test for oxygen is. Okay, so you need to remember your chemical tests for your gas. So our tests for gases are as follows. Chlorine bleaches damp red litmus paper. Oxygen relights a glowing splint. Hydrogen burns with a pop, and ammonia turns litmus, damp red litmus, blue. Okay, well, we're missing one there, aren't we? So I was missing the carbon dioxide there, and carbon dioxide turns lime water milky, so just added that one in. So we've been asked what the test for oxygen is, so you need to remember that test, you need to have learnt it off, and the answer is to relight a glowing. Now moving on to part 3, manganese oxide is a catalyst for the reaction. That's MnO2. How did I know it was MnO2? Well, I could have just remembered, or I could figure out by the fact that it's manganese 4, telling me that transition metal manganese is a charge of +4, or an oxidation state of 4. And oxygen, we already know, has a charge of -2, or an oxidation state of 2. Okay, so that would give you Mn2O4, or more simply MnO2. So the formula of that compound is MnO2. Okay, but this is unrelated to the question. The question is plainly asking you, state and explain the effect of a catalyst on the rate of reaction. Okay, so what does a catalyst do to a rate of reaction? Catalyst will speed up the rate of reaction. So we'd want to use a better word than speed up, so we're going to use the word increases. So we have increases the rate of reaction. So that takes care of our stating, and our second part is to explain. So how does it do that? How does it increase the rate of reaction? So it does that by providing an alternative pathway. Now you could explain how it provides an alternative pathway. You could talk about things being adsorbed onto the catalyst. So that would also be acceptable. But you then need to explain why that alternative pathway is relevant. So that alternative pathway will have a lower activation. Okay, so we wrote down has a lower activation energy, and I was just throwing a couple of extra words in to make this read as a sentence. Increases the rate of reaction by providing an alternative pathway with lower activation energy. Increases the rate of reaction by providing an alternative pathway with lower activation energy. So this would be 3 marks, 1 for increasing the rate of reaction, one for having the alternative pathway, and the third would be for lower activation energy.